going to go ahead and do these three graphs that I had a little difficulty with last time and see if I can do them today. All right, so, and I'm going to use the calculator to help a lot. All right, so what we're going to look at are some transformations. Our parent function here on this problem is going to be 5 to the x right? We have 5 to the x minus 5, and we have a plus 2. So it has two things going on. It has a horizontal shift. Remember, it's to the opposite place when it's horizontal. So this is going to be a shift to the right. Five places. We also have a vertical shift up 2 spaces. The vertical shift will affect your asymptote, right? And so let's mark these. Shift right 5 places. Shift the graph 5 units to the right. So we're good there. A vertical shift up 2 places. So we want to go up. All right, that's our first 2. All right, and we want to graph, and we're going to have to put the asymptote on. All right, so our original asymptote would be 0. Our asymptote is going to go up 2. Let's go ahead and pull the graph. All right, and I'm going to just put in this new function. I'm not going to bother putting the parent function. I think that's where I got in trouble before. Okay, it's nice to see both. So y equals, I'll put both. Okay, if I get in trouble, I'm already in trouble. Okay, I have to do 5 to the x. All right, that'll be my first one. That's the parent, and it will graph first because I put it in first. All right, and I'm going to put 5. Because it has more than one thing here, when you enter that in your calculator, we'll put the to the power. You need parentheses to put it in your calculator. That's an important piece to know. X minus 5, close, and now you're plus 2. And if you have one of the TI-84s, remember you have to go down before you can do that from your cursor position. All right, so we're going to graph. It'll do the first one, and then it will do the second one, and you will see it shifted up 2. All right, so we're going to graph. All right, here is our first one. This is the asymptote. The other asymptote on the original is right on this x-axis. All right, so that is what you're seeing here is the asymptote. I'm going to move this down a little bit to make sure it is in my recording. All right, so I wanted you to see both of those. So our asymptote is here. This is the graph we want. Right, I'm going to go back and show you a trick. I want to turn this first graph off. I wanted you to see these because I want only the table from this one. Right, I'm going to go ahead and pick off my asymptote. My asymptote is going to be y equals 2. This vertical, original asymptote is y equals 0. This vertical movement is what affects your asymptote. Okay? So it is y equals 2. And I want my table to get 2 points. All right? Now, I'm going to show you a trick. I'm going to go back under y equals. I am going to turn off this first equation. So I'm going to get back there under the equals, and I am going to click enter there, and that will toggle that one off. right? Now, I only want the first one to show up, so I'm going to click graph again, and it's only going to show that one. Now, when I hit my second table, I should only get the table for that one. Okay, so now it shouldn't be confusing. We will need 2 points, and since we should be able to use any 2 points, let's see. I want the point that would make this exponent part 0. So let's use a 5 there. A positive 5. If we put a positive 5, would we get a 0 there? That would make a 0, which would make this piece 1, plus 2 would be 3. All right, so for my points, I am going to use a 5, comma 3. For my other point, because I have to just click 2 points, it says I can use any point. Let's go back down through here. Let's use negative 2, 2. Right, to make the software work right, I think you have to use the point first that will make this variable part 0. So whatever plugs in here will make this piece 0, I think you have to use for your first point to make the software tool work right. All right, now we'll go on and see if we can do the graph. All right, so first of all, we're going to click to make the asymptote, and it says y equals 2. So we're just going to click. I did not click the tool. All right, I clicked there, and then I'm going to go up and click. I didn't ever click this tool. I can click it. All right, so, and it erased that. All right, so I'm going to clear. All right, I'm going to go up and click this. All right, there's my asymptote. Now I'm going to click the point 5, 3, 5, 3. And I'm going to click the point negative 2. Negative 2, 2 should not be right. Why is it telling me that? Okay, because that's the asymptote. Right. It's just getting closer and closer. All right, so I don't want that point. Let's get a different point. All of those are just getting closer and closer to the asymptote. I don't want that point. Sorry, that was a bad one to choose. And Mrs. H thought she could do this right this time. All right, so I did 5, 3. Let's do 6, 7. 5, 3, and 6, 7. See if we can get a graph with that. All right, so we have to clear it out. We have to put the asymptote on. Right, we're going to do the point 5, 3. And we're going to do the point 6, 7. 6 and 7. All right, there we go. Now we have it. That other point, it doesn't really land on the asymptote. I should have caught that. It just gets closer and closer to the asymptote, and the calculator just ends up giving you that because it's getting closer, 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 but it's not actually the 2. It's closer, 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 but it's not actually that value. All right. I guess that was a good lesson to see. All right. Domain of H. We'll pull the calculator back up so we can see it. right? It is going to be from negative infinity to infinity. And we'll do negative infinity, comma, infinity. Hopefully I did a comma. I did not do a comma. All right, the range. Range is going to go from the asymptote, which you are not touching, to infinity. So you're going to go from 2, comma, to infinity. All right, and now let's submit. Oh, I left off the last piece. It is y equals the equation of the asymptote. This is going to be our y equals 2. And you do have to write it as y equals. Mrs. H just wants to see all green at this point. Okay. All right, so I am going to pause the video there. I'm going to go ahead and look at question 7. And this one, another graph. It has 2 things done to it. First of all, our parent graph would be 3 to the x. Right. This one has a horizontal reflection, this negative x here. That means it flips across the y-axis. Right, and it has a vertical shift of 2. This will affect your asymptote. Your original asymptote would be y equals 0. Your new asymptote will be y equals negative 2. Right, and I'm going to pull up the calculator. I can go ahead and mark these first 2. We are going to reflect the graph around the y-axis because it's horizontal. And we're going to shift the graph down 2 units. Those are easy to pick off. All right, let's get our calculator. And we're going to go under y equals, and we'll have to turn it on first. We'll clear y equals, we'll clear everything, clear everything. All right, first we'll put in 3 to the x, and we'll graph it. All right, and we'll go back under y equals, and we're going to put in 3 to the, I'm going to use parentheses here. I'm a little conservative. I don't know that you have to with the negative x, but we want the whole thing to go. So we will use parentheses. Parentheses are your friend. And then you want a minus 2. And we will say graph. All right, so watch as this one happens. And I'm going to move it down a little bit to make sure it's in my recording screen. All right, so there is your new asymptote, negative 2. So there's your new graph. You see what it did? It flipped across this axis, your new asymptote. Okay, I am going to go back under y equals. I am going to again toggle this first one off. And just say graph again. That's the one I want. I am going to go to second table to get my points. I do want the point that will make this piece 0, and it will be 0 itself. So I want 0, so it will be 0, -1. Right, and I want another point, and I don't want to end up getting the asymptote. Whoops. So I don't want a point that gives me -2. These are going to end up eventually giving me -2, so I need to go the other way. All right, so pull this back up, put it over here. All right, so how about -1, 1? Those 2 points should do it. All right, now I can get the calculator out of the way. Okay, so on my graph, first should be my asymptote, which is -2. Click. The point 0, -1, and -1, -1, 1. I never did have to click that tool. Let's put the graph back on here. It looks right, so you don't really have to click the tool. You click a point for the asymptote, get 2 points. Don't click the one if you're matching to your calculator that actually hits on the asymptote because it doesn't really hit there. Okay, your domain, -infinity to infinity. Range, -2. You will need parentheses because you're not touching that asymptote. Whoops, that is not -infinity, it is -2, comma, infinity. Your equation of the asymptote is y equals -2. Yay, we have green. And then we'll look at whatever pops up, okay? All right, and I did put your test scores in there, so you should see those now. All right, so this was really just using the tool and using your calculator and the asymptotes a little bit. Right, so this one was the e to the x function. And so first we'll do the parent function. Parent function here is e to the x is the parent. We have 2 transformations. So the one we have is e to the x minus 3 plus 4. It has 2 things on it. It has a -3 with the x and a +4. Remember, this will be a horizontal shift and it will go the opposite way. So this is going to shift to the right. Three places. And this +4 is a vertical shift. This is the one that will affect your asymptote. It will move your asymptote up and down. Your original asymptote with these exponential functions is y equals 0. And so now it's going to be y equals 4 will be your asymptote. And an asymptote is a line that things go toward. So y equals 4 is what we're going to go toward. Let's go ahead and mark our things. So we're going to shift to the right 3 places because we do the opposite there. So shift to the right 3 places. And we're going to go up 4. Not a stretch. It's just up 4. All right. And then for our graph itself, oh, they're not going to make us do it. Sorry about that. I wanted one where I could show you. And this one is just giving us the graph. So I wanted to use the tool for you. Sorry about that. I already did the 2. Okay, let's pull it on the calculator. All right, and so what I am going to, sorry, I thought I turned that email off. Let me just check and see if it is. I'm going to turn her off. It's the vice president, but I don't want to talk to her. Okay. All right. She didn't want to talk to me either. It's just an invite, but I don't want the thing to ring as we have class. Okay, I thought I already turned it off. Okay, let me clear this out of our calculator. Right, I am going to put the original in, and if you haven't used the E yet, E is a number that it's an irrational number. It goes on and on. And to find it on your calculator, it's above the divide. So we're going to do second divide. And you'll see the E. And E is like 2.7, and it goes on and on and on. It does not repeat, and it does not get a pattern. So we'll put the E to the X. That's the parent. And then we're going to go ahead down here and put the one we really want. So second E, something that's important here, because you're going to put more than one thing in here, you need parentheses. So we'll put our X raising to a power, use parentheses. So you want X minus 3, close, and plus 4. Right. Now, when I tell this to graph, it will do the first one, and then it will do the second one. So we'll watch as that happens. Graph. This will be the standard one. Right. Looks like your regular exponentials. Right. That one is shifted up 4. This is your asymptote. That's the one we want. All right. So I'm going to show you a trick here. Let's go back into the y equals. And I'm going to turn off that first one. I don't really want to concentrate on it. And if you go back onto the equals and you click enter again, you're toggling, and that one is now going to turn off. So I'm going to hit graph again, and it's just going to show me the one I want. So this is the one I want. I'm going to move this over because this is a multiple choice thing. And I am going to pick out of these my graph. That kind of looks like the right one. If my graph is moved over the appropriate amount of spaces, it definitely is the right height. This second one is wrong. It's moved down. That one is moved to the left, so it's wrong. And that one is down. So this one is the right choice. And let's see if there were any more questions. Okay, so it's going to ask me domain. Calculator is a good thing to look at for domain. it's going to go to negative infinity and positive infinity. We can type that in. If you click interval, it'll help us a little bit. We can do that. Negative infinity, comma, and positive infinity. Save us the typing. Range. We'll go ahead and do that interval button again. Now, you never touch that asymptote. You're just going to go toward it. And so you want a parentheses for your range. You don't get to touch the asymptote. So we want parentheses, parentheses, right? So that 4 is going to be the first piece. It didn't put, I guess I didn't click it. All right, so that is positive 4, comma, and infinity. All right, and the equation of our asymptote, I did that to begin with, is y equals 4. All right, there we go. There's all our parts. And that graph is also going to go ahead and give you those pieces on it. Let Leon in. I'm sorry this one was multiple choice. I thought that it would let me show you the tool. But you can go back and if you watch those first, I did the first 2 problems on this video, the 6 and 7. So they'll be on there. All right, so you can test those graphing. And we'll get to some of the logarithm ones. The other questions in here, and you will see these questions again in like a couple of sections where we really deal with equations. The exponential equations, this first section that deals with them, it's an easy rule, but sometimes you have to play with these problems. If you can make the bases the same, you're allowed to set the exponents equal, and then you can solve. And so our first one here is pretty easy. Some of the others are a little tricky. You have to really work on those. So we're still in 5.1. And I'll just pick a few. All right. So we have 3 to the n equals 27. If we can rewrite these with the same base, then we can forget about the bases and just work on the exponents. So the goal would be to try to rewrite 27 as 3 to some power, or make them the same base. And we can. 27 is 3 to the 3rd. So this one is a pretty obvious problem. And you would check it on your calculator. Right? And so the base is the same, so you're allowed to drop the base, set the exponents equal, and this one is actually already solved. And you're done. That's the answer. N will equal 3. So it's good. All right? This one is going to be a little bit more work. It's not quite as obvious what we're going to use here because we don't have something right away that we're going to use. So we're going to have to work on that. We can go down to 2. We can try to use maybe a 4. So let's see. I know we can do 4 for 64. So let me try with our calculator and see if we can do 4 to some power. So we're kind of playing a little bit. So if we do 4 to the 3rd, that gives us a 64. Let's see if we try 4 to the 4th. what we get. It's going to be big pretty fast. 4 to the 5th. All right, so we have a candidate here. Okay, and that's what you have to do is just play a little bit. All right, so this is 11. I'm going to write the original problem. So we have 1,024 to the x equals 64. So we didn't really use anything that's there. I'm rewriting both of them. So 1,024 I'm rewriting as 4 to the 5th to the x, and 64 I'm rewriting as 4 to the 3rd. Right here you have power to a power. So you have 4 to the 5x equals 4 to the 3rd. Whoops. Now you can set these equal. So you have 5x equals 3. So once you have the bases the same, you can drop the base and set the exponents equal. And then you can solve. So 5x equals 3. That's all you have to worry about. You are going to isolate the x. So you're going to divide by 5. So x equals 3/5. Okay. All right. Let's try 12. All right. This one looks a bit different. So we have 2 times 5 to the x plus 38 equals 288. Right, your first job is going to be to isolate that piece that's to the power. So let's get this 38 off. Always take off anything that's added or subtracted first. So let's subtract this 38. That'll go off. So we're going to have 2 times 5 to the x. All right, 8 minus 8 is 0, and 8 minus 3 is 5. All right, divide out your 2. So I have 5 to the x equals 125. Right, and this actually is turning out really nice because 125, you can play with it, but it's actually 5 to the 3rd. If you just test this base, 5 to the 1 to the 2 to the 3, it will give you 125. Once you get the bases the same, you can drop the base and set these equal. So you have x equals 3, and it's already solved. So it's done. Even though it looked really hard at the beginning, remember, isolate your piece that's to the power, and then you can drop those bases, and you're good. So these are actually nice problems. All right, let's see. This one, a fraction to a power. Remember that when you have something to in the denominator, the way it goes down there is something to a negative power. All right, so I would rewrite that piece to start with. So instead of this fraction, because I don't like that, that's hard, I would rewrite this as 5 to the negative 1. And then that's to the x. So this will be 5 to the negative x. Right, because those would multiply. And then if we can get this 625 as 5 to some power, and I am pretty sure we can, I'm going to just play with it on my calculator. Make sure I got that in that record channel. let's see. So, I know 5 to the third is 125, so I'll try 5 to the fourth. 625. There we go. All right. So, I can drop the base, set the exponents equal, and then I can solve. All right. So, I have negative x equals 4. All I have to do is divide out this negative 1. So, you have x equals negative 4. All right. So, not too bad, huh? All right. Let's see. Wasn't going to do them all, but this one, you have to work on it a little bit. You're gonna have to pick a different base. I think I would go with a 2, and I don't like that fraction, so I'm gonna put that as 2 to the negative 2. And I bet some of you guys have already figured this one out. So I would probably start over here because I don't want to deal with fractions. All right. And so 2 would get it, 2 to the negative 2 would get it down here. All right. Because 2 squared would be 4, but making it negative exponent puts it in the denominator. So 2 to the negative 2. That's this one. All right. 8 is 2 to the third. So if I do 2 to the third to the n, all right, that's 8. All right, so we're good there. So this will multiply. So this is 2 to the 3n equals 2 to the negative 2. Now you can drop those bases, set this equal, and you can solve. So 3n equals negative 2. Forget about the bases. Isolate your n. So n equals negative 2/3. All right. I think that's enough of those. Let's see. Oh, woo, that one looks a lot different. Maybe we should do one more, huh? All right. We'll do one more of those. Let's do 17. Then we'll go look at some logarithms. Okay. Yeah, I think you get some quadratics in these, so we better do a little bit. So we have e to the 24x minus 120 equals 5x squared. Whoops. Equals e to the 5x squared plus 5x minus 150. All right, so the rule says if the bases are the same, you're allowed to set the exponents equal. So you actually don't have to do anything to the bases. You can set the exponents equal right here. And forget about the bases. So you have 24x minus 120 equals 5x squared plus 5x minus 150. We have a quadratic equation, which we know how to do. Now, we would like to keep a positive coefficient on the x squared term. So we're going to move terms to the right, and I'm just going to get a little space. I'm going to subtract this one. I'm going to add this one to get them to the other side. This is going to be a 0. All right, so I'm going to keep the x squared. I am going to subtract 24x. So I'll use a little calculator help here. so I don't mess it up. So I have 5 minus 24, a negative 19x, and I have a negative 150, and I'm going to add 120. All right. And that should give me a negative 30. All right. Okay, let's see. Not such a nice problem. We could try to factor it. Let's see if we can factor it really fast. It might factor and it might not. That is the issue. I'm only trying it because 5 is prime. Different signs. Over here, I have 1 times 30. I have 2 times 15. I have 3 times 10. 4 doesn't work. I have 5 times 6. And you have to flip them all over. Now, there are a bunch of them I could throw away because a common factor in the first parentheses. So anything that would give me a common factor with a 5, I could toss. All those I could toss. All right, so a 6 and a 5. Maybe this one. Let's try it. All right, there's a minus 25x plus 6x. That is 19. And it's a negative 19. All right, so Mrs. H got kind of lucky there. And it did factor. And so our solutions are going to be, I could have gone quadratic formula too. All right, so 5x plus 6 equals 0, and x minus 5 equals 0. So this one is going to be 5x equals negative 6. X equals negative 6/5. This one, x will equal 5. All right, and you could have also factored this with grouping, where you split the middle term, you multiply 5 times 30 is 150, and then split the middle and make 2 terms, right, and go with grouping. That would have also been an option. All right, let's see if we have the right answers. Right, negative 6/5 and 5. Okay, so that was a little bit different. Okay, let's go to the next section. So this was just 5.1. And let's look at some logarithms. Logarithm is the inverse of exponential functions. And the best way to graph a logarithm function is to graph the exponential function and then remember that it is the inverse. And that's exactly what I would do. I would get the chart for the exponential and I would flip the x's and y's to graph the logarithm. That's how I would do it every time. All right, so let's see what we have in here. There are lots of rules that you want to make sure you memorize, and I'm going to just pull something up real quick if I can pull it. It is in your um, Blackboard shell. Maybe I'll do it at the end so I don't mess this up. But in your Blackboard shell, under your chapter materials, it's like a study thing at the end, and it has all of it's in the review folder. It has all of your properties listed, and it's really nice to have as you go for this particular chapter. It's a real important chapter. All right, so let's see what we have. And this, all right, so this section is going to have you switch a lot between exponential form and logarithm form. All right, and so what you're going to do is you're going to spiral around this equal sign. So you have b to the x, and the base is the same in both, right? Let's see, we are now in section 5.2a. Right, and we have 3 equals cube root of 27, or 27 to the 1/3 power equals 3. So you write it to a power. This is the exponential power, and they want us to write the logarithm form, right? And so your base will be the same. So it's going to be the log base b. You're going to go around the equals. You're going to spiral around the equals. Whoops, not this, right? Your base is the same of 3 equals the exponent is the answer. All right, so start at the base, the log base 27 of 3 equals 1/3. So that you're just switching, these are equivalent. And let's look at this. Log base 27 of 3, and I'm not real good about putting my parentheses there, equals 1/3. So you're always doing a spiral around the equals. Start every time at the base. And sometimes you go counterclockwise, sometimes you'll go clockwise. But base is the same in both. All right. Write the following exponential in its equivalent logarithm. All right, you've got your base. So this was 1. So we have 10 to the x. They want us to go, 10 squared equals x. All right, they want us to go to the equivalent logarithm form. All right, here's your base. So we want to go log base 10 of x equals 2. And 10 is called the common log. And so normally you won't write that. In this problem, they probably want you to just because you're getting used to it. But when you don't see a base on there and it just says log of x, that is automatically a common log, and that is the one that you see on your calculator. So they did not write it. They probably would count it right if you did. All right, let's see another one. And there's a lot of problems in here because once you get used to it, they go really fast. Okay. Let's see. Write it in the equivalent logarithm form. Okay, so start at your base. Right? You have exponential form, so we're over here. So 1 over 1024 equals 4 to the negative fifth. So this is exponential form. Here's your base. So log base 4, right? And you're going to go from there to the other side, land at your exponent. Log base 4 of 1 over 1024 equals negative 5. Sorry about the color switch there. There you go. So you're just spiraling around that equal sign. All right? I think that one would be easy. You start at the 9, spiral around, log base 9 of 729 equals 3. I won't even write that one down. That one's easy. Let's do 6. All right. This one has E. When you have E, you're going to use a different logarithm form. You're going to use what's called the natural log, and its base is E. We use ln with it. We can write it the standard way with log, but it really, then we will switch and put it the way it should be. Okay, so E to the 6th equals X. If you're going to write it in logarithm form, I'll go ahead and write it the way we've been doing. You still start at your base, right? And so E log, start with log base E of X equals 6. Doing your spiral around the equals, finish at your exponent, right? The normal way to write this, anytime you use E, so your two bases that you're going to use a lot are base 10 and base E. Those are the ones that your calculator uses. Common log is base 10, that's log. Natural log uses base E, and on your calculator, and I'm always going to use a cursive L so that it doesn't look like a 1. It's ln on your calculator. So this will be ln of X. That's all you're going to see because it's automatically base E. That is what you're going to see, and that's probably what they're going to put for the answer. I don't think they would count you wrong if you put this. Let's type it in. All right, if we typed in, let's see what we would type here. Functions maybe. If we typed log base E, I did E from the keyboard, clicked with my mouse, X. Now I'm doing equals from the keyboard. Whoops. All right. So I'm going to have to backspace. I need to get outside that parentheses. Now put my equals. It does want an equation there. All right. I'm going to check that and see if it's okay. This is really what they wanted, but I'm going to check that and see if we get away with it. We did. All right. So going this way, this is really the best way to write it, but they would accept that. All right. Now, let's see. The following logarithm. Now, here's some that's going the other way. So we can look at some of those, a few of those. What's my time like? All right, we're doing okay. Okay, so y equals log base 3 of 12. You're just going to go the other way you're still going to start at the base. Every time you start at the base on these. So you're going to do 3 to the y equals 12. You're still spiraling around that equals 3 to the y equals 12. There's exponential form. Okay. 7 to the third equals 343. I'm not even going to write that one. All right, write 11. It'll take me longer to write down the problem than it would to do it. So don't be upset when you see that there's a whole bunch of problems here. They will be fast, okay? So 8 to the negative 2 equals 1 over 64. It's just learning to switch the forms really fast. Okay, that's a bunch of switching forms. Find the exact value of the logarithm expression. This is where you start using your rules. And so you want to make sure that you know those. And one is that you can rewrite this, and your you want to get, if you can rewrite this so that your base is the same as what you're taking the logarithm of, so we can rewrite this as 7 squared. Once you get these the same, the answer is the exponent. And it's done. So this is your goal, to make this as 7 to some power. The answer is the 2. So that will be your goal. You want to make sure that you can memorize that rule. Here's one. So you want to rewrite 216 as 6 to some power. So you're going to play with it on your calculator. All right, it's not going to get too big. Let's try 6 to the third. All right, there you go. So log of 6 to the third. There you go. Those are the same. The answer is 3. So that's your goal. These are like little puzzles. All right. When you have a fraction, it's going to be a negative power. Let's try this 17. That's a little harder number. So these are going to be little puzzles for you. But it's in the denominator, so it's going to be a negative exponent. So I'm going to pull a calculator here. And let's see, I'm going to try 7 to the 4th. Hey, lucky day. But it's in the denominator. So I'm going to need to do 7 to the negative 4. All right, that would move it to the denominator and give me this. Okay, so those are the same. That's my answer. Okay, so remember, a negative exponent makes it in a fraction, puts it in the denominator. All right, let's see if we have one with a radical. All right, there's your one with the denominator. Here's one with a radical. Right? Remember, a radical is a fractional exponent, right? And so the index is your denominator. So let's rewrite this one. So log base 10 of 10, this would be 1/4. And you already have this the same. The answer is 1/4. So just rewrite those. Okay. This one you want to rewrite this piece. So 20. We have log base 5 of 1/9. All right, so you got a couple of issues going on here. You've got a radical and it's in a denominator. So 2 things to work on there. So we'll rewrite it. All right, so it is a 5 is going to be our base. It is going to be to the 1/9, but it's in the denominator. So it is going to be to the negative 1/9. I believe would do that. All right. So if it was up here, if it was not a fraction, if it was just up here, it would be 5 to the positive 1/9. Yeah. So this will be our answer. There you go. All right. So a fractional exponent is a radical. Keep that in mind. If it's in the denominator, it's a negative exponent. Right? That one's not a radical. It is just a plain fraction. Let's see. Let's see about that one. Too many fractions and stuff here. Let's see what we have. I don't even see a variable. Okay. This is H just spacing out a little bit there. That was 21. So log, I don't like this one, I can tell you. 1/11 of 1/121. I want to make this look like this. Right? It almost does. If this is this squared. All right, so I just have to make this match this, and then it will fit my rule. This is this squared. So it's going to be 2. That's a weird one. All right, this one's going to kind of be the same thing. You'll just see 11 to what power is going to give you this. Whoops. $11 to the 3rd. So, what we have is log of 1/11. We're rewriting this as 1/11 to the 3rd. These are the same. That's your rule. So the answer is the exponent. Okay. All right. Let's see if we have some different kind of questions. Yeah, you can play with that. This will be a little harder. Probably going to have to do a square root to make that work. Right. Because this is smaller than this, and you want to rewrite them in terms of the same power, in terms of the same base. So if you could rewrite this somehow as 16 to some power, well, the square root of 16 is 4. So if you rewrote 4 as 16 to the 1/2, because the square root of 16 is 4, right? Then you've got this base the same. Your answer is going to be 1/2. So your goal is to get this the same. So you'll have to play when your number is smaller like that. When you've got this kind of situation, that's when you want to get a root there. And that's what's going on here because we had that pattern up above. This one's going to be easy. These are already the same. It's going to be 1. The next one, weird numbers, but they're already identical. It's going to be 1. All right, so anytime you're taking the log of the same thing, and that's another rule, right? So when we could get them the same, it would be the exponent. This is the next rule, and we can do it on this weird one. Okay, when they're already the same, the answer is 1. Okay, 29 brings up the next rule. So you want to look these rules up and have these rules down. I'm going to pull that sheet up in just a second because we're almost out of time. Anytime you take the log of 1, the answer is 0. So that is your third rule. Doesn't matter what the base is. So you want to make sure you memorize those. All right, here's another one. Doesn't matter what this base is, you're taking the log of 1, the answer is 0. This one, your base is already the same, the answer is 6. All right, so those will be the fast for you. I am going to see real fast if I can pull up the place where you are going to find, looks like I have lost my page. Okay, let's see what I got here. Surely I didn't lose that page. Let's see, Zoom I have. Share screen. I would not have logged out of Blackboard. Okay, maybe I did log out of Blackboard. Okay. Maybe I can open it right here. There it is. Okay. We'll just make it big on here. And this is us. So, what I wanted to show you is under your content, and here we are, chapter 5. It is under this reviews for chapter 5. And review for test 4. It's the study guide for test 4. It's not the problems. It is, when it went on my other computer. I have 3 monitors running. That's why it gets a little crazy here. But I will pull it back down here. Okay, this page, and I'll see, can I make it bigger? And I didn't go over any of those word problems with you from that first section. They must have been at the end. You definitely want to go back to those with your compound interest from our first section there that we didn't do. They're not hard, but they will use either this first formula, and you will be given the formulas on your test. Compound interest and continuous compounding. This is compounding with intervals. You just have to know your intervals and you plug in, but practice it on your calculator to make sure you're entering it right. And continuous compounding always has the E. These are the log properties I wanted you to make sure that you know. All right. These are the ones we were just using. And when you get these bases the same, if there is no exponent, it's 1. This is the one we were using a bunch. When you can get the bases the same, the answer is this exponent. If there is no exponent on there, it's 1. The log of 1 is always 0. And this one, I don't think it uses a bunch in your software, but it is also a property. If you are from a base to a log and that base is the same, the answer will be whatever you're taking the log of up here. It will be that x. But these properties are super important. They work the same with base E. Just memorize those. If you have a printer and can print this page out, it's real important. And it is in the review section, the study guide page. Super important for you this time, more than any of the other sections. And then when you get to that 4.3 section, here's 3 more that you want to make sure you memorize. Okay, I'm going to stop there for today. I did skip these problems, these word problems. They're not hard. Practice doing them in your calculator, though. You will use your calculator the whole time on those, but it's making sure that you enter them right. Okay, you guys have a great day. Send me your questions that you want for next time. And if you have some more, I don't mind to do videos early. I can do a problem or 2, and I will stick them up there for you. So if you get stuck, please send me an email with a problem number. I will do yours exactly from your homework for you. Okay, you guys have an awesome day, and I will see you soon. Bye.